So carbon has how many electron dots? 4 electron dots, okay. Monty, how many electron dots does hydrogen have? 1. How many electron dots does hydrogen want to have in order to be as stable as it can be? Laura? Huh? I can't hear you. 3. Okay. Let's look again at the orbital notation for hydrogen. I'm looking for my periodic table here. You got this stuff you have to kind of remember, okay? You got to keep up with all of this. We built on this in the last unit. So hydrogen has an orbital notation where we have how many electrons? The hydrogen is located right here. How many electrons do we put on hydrogen? 1. Okay. Are there any p orbitals at all in this first row? No. So to fill up the valence level of hydrogen, we can only fill up an s sublevel. Got that? How many electrons can I put in an s sublevel, Laura? Just 2. So that's all hydrogen wants. It just wants 2 electrons, okay? All right, so we can, if it can share electrons so it can have another electron right here, with this arrow pointing up and this one down, then hydrogen has a full valence level, and that makes it more stable. It will have the electron configuration of helium. Helium is one of the noble gases, and these are very stable elements. Okay, Tevin, you with me here? Okay. So if I'm going to get to a point where I'm sharing 2 electrons for hydrogen and 8 for carbon, then I can start with this sharing arrangement. So I'm going to go from the electron dot formula to a sharing arrangement. And this sharing of electrons here between the hydrogen and the carbon now gives hydrogen 2 electrons. Okay? But Ty, how many electrons does carbon have? Not now. Now it's sharing. It's got 5 now. But it wants how many? 8. Okay, good. So, Jonathan, John, how many more how many more hydrogens do we need to share on this carbon then to give carbon 8 electrons? 3 more. So we're going to put 3 more hydrogens around here. Okay, so all of this is review so far. This is stuff we did last week. Okay? So there's our sharing arrangement. We're going to call this the sharing arrangement. That's the name.
I don't care about hydrogen. I thought it needs 8.
Not everything wants 8. Hydrogen only wants 2. All the other nonmetals are going to want to have 8. Okay? So that's the sharing arrangement. And then from the sharing arrangement, let's see. Michael, what are we going to do next then from after the sharing arrangement? Lewis dot formula. Okay, good. So here's the Lewis dot formula. All we're going to do with the Lewis dot formula then is to take and squeeze the electrons in between the element symbols. Okay, and we do it in this fashion. Okay, now I explained why we do it in this fashion last Thursday. I don't need to go over that again, but they're going to be arranged up and down here and side to side here. Okay? You have to arrange them in the correct way. All right? Okay? All right, Gracie, from Lewis dot formulas, what are we going to draw next? Lewis formulas. And we just replace what? Our dots with a line. Okay, good. So any shared pairs, and only shared pairs, get replaced with lines. Okay, and so this is the Lewis formula. Okay, now, this is like a flat arrangement. Okay? It's like I took that tripod we had a while ago and flattened it out on the table. Okay? And that's not really the shape it's supposed to be. In 3 dimensions, it's going to be a different shape. And it's a little bit tricky if you've never done it before to think in 3 dimensions. How many of you taken art before? You know what perspective is? we're going to do a simplified perspective. Okay? We're going to create a way of making a drawing that has a simplified perspective to show that how those things are arranged in 3 dimensions. You with me over there, Rachel? Okay? All right. So what I'm going to do is I'm going to start with the Lewis dot formula. Okay, we're going to start with the Lewis. When we start drawing 3 dimensions, we're going to start with the Lewis formula. When we start drawing molecules in 3 dimensions, you start with the Lewis formula. Okay. You're going to count the sets of electrons around your central atom. Count the sets of electrons around the central atom. Count the sets of electrons around the central atom. Okay. Sets can be 2, 4, or 6. And then we're going to choose the electron pair shape, and I'm going to show you what that is in a minute. The electron pair shape that gets the sets as far apart, it's AR, as possible. Okay? Choose the electron pair shape that gets the sets as far apart as possible. All right. Now don't misunderstand. This arrangement here, where it looks like I've got the electrons 90 degrees apart, is not as far apart as we can get them. We can get them further apart than that if we move some things around in 3 dimensions. So we're going to take this set and turn it like that a little bit and spread them out some more. And we're going to get 109.5 degrees between those sets of electrons. Okay? So instead of 90 degrees, I'm going to start with the electron pair shape. I'll start with the carbon here. I'm going to have a set of electrons up here. I'm going to have a set of electrons that are 109.5 degrees over here. Okay. To get the next set 109.5 degrees, I've got to come out from the paper. And the way we show that is with a triangle shape. Okay? Now, it's okay to draw it like that. Really, I guess you're supposed to have it as a black triangle, but that's not a big deal if you don't when you're drawing it by hand. Okay? And that's the one that's coming out from the paper toward you. Okay? Then we need a set of electrons that are going back behind the paper. So instead of being straight out like that, they're actually going back behind the paper. 109.5 degrees. Now this is where using your imagination is going to be very, very helpful. Those of you who've taken art, you probably understand perspective and kind of see what's going on. And those of you who haven't, you've got to use your imagination. You have to understand, even though we're drawing on a piece of paper, even though these are just lines and triangles and dotted lines, you have to use your imagination to imagine where those shapes are going. Okay? That we've got 2 lines that are flat on the plane of the paper. We've got a triangle which brings those electron dots out toward you, and a set of electron dots that means they're going back behind the paper. Okay? So we get a kind of a tripod at the bottom with this sticking straight up at the top. Does that make sense? Now this shape is called a tetrahedral. A tetrahedral. Okay? And this is the electron pair shape we're talking about. All right? Now that's not the end of it because we don't yet have a molecular shape. What we have right now is an electron pair shape, and what we want to find is a molecular shape. Okay? We got one more step for this particular drawing. What we're going to do is we're going to replace, the last thing we're going to do is replace here, last thing we're going to do is replace sets of electrons with atom symbols where the electrons are shared. Okay? Only where electrons are shared. We're not going to replace lone pairs. Okay? Do not replace lone pairs of electrons. Do not replace lone pairs of electrons. Now in this case we're not going to have any lone pairs. Okay? But if we have any lone pairs we're not going to replace them. Not at this stage. Okay? Alright, so let's go back up here. We have all four of the sets of electrons. This is a set right here. Now you don't have to circle the set. I'm just circling it to show it to you. This is a set. Okay? 4 sets. And all 4 sets in this drawing are shared. In this molecule. Now, not all molecules will have that happen, but in this particular molecule, all 4 sets are shared. Okay? So that means we're going to replace all 4 sets in this drawing with the symbols for the atom that are on there. So what I'm going to do is I'm going to draw that central carbon here. I'm going to put the 4 arms on here like this. 4 arms or legs, whatever you prefer to call it. Okay? But every place I had those electron pairs, so we had electron pairs at all 4 corners. What my recommendation is, and what I'm going to ask you to do every time, is to do this in pencil. Redraw exactly the same drawing. Redraw exactly the same drawing. Then, after you've redrawn exactly the same drawing, replace only as many sets of electrons as you need. Replace only as many sets of electrons as you need. In this case, we are going to replace all 4 of them. So I'll erase the pairs of electrons now and replace them with the hydrogens. What? You're going to redraw exactly the same drawing, and then you're going to, and do it in pencil, then you're going to replace only the sets of electrons that you need to replace. Okay? What now? Oh, do not replace lone pairs? Okay. Alright. So now, we still have the same shape here. We've got these 2 lines at 109.5 degrees. This triangle, which is coming out from the paper, is 109.5 degrees. The dotted line is showing back behind the paper at 109.5 degrees. So this shape is still a tetrahedral. Okay, the tetrahedral is still the shape. All right, but now that we've replaced, now that we no longer have any lone pairs of electrons, we now have the molecular shape. Okay?